Hello and welcome. In this video, we're going to discuss Ohm's law. Ohm's law is how voltage, current, and resistance relate to each other, and it can be expressed in three different forms. So the first form would be our main form, current. Current is equal to voltage over resistance. Right? I equals V over R. We can use our Ohm's law triangle here to find each one of these. We can say voltage is also equal to current times resistance. And then we have one more here that we can pull out that says resistance is equal to voltage over current. Right? So if you need to find Ohm's law, you can just pull out your Ohm's law triangle and circle out the equations that you want to use to solve. This equation gives us a couple of different expectations. We expect resistance and current to be inversely proportional. So if we have a high resistance, we have a low current. And if we have a low current, we have a high resistance in the circuit, or we expect a higher resistance in the circuit because of the lower current. Voltage and current are directly related, meaning that if we have a higher voltage, we have a higher current, and if we have a lower voltage, we have a lower current. So they are directly related to each other in terms of scale and magnitude. Current is restricted by resistance and allowed by conductance. Remember, that's the opposite side of that same coin. So if we had a conductance value and we wanted to know the resistance, we can just say 1 over R, or we can say that the resistance is equal to 1 over G, right? And those are going to be the same side of the coin in terms of resistance and current flow. So every single resistor is going to have a conductance value, and every single conductance is going to have a resistance paired with it. So what happens when no current is in the R equals V over I? So we're going to plug that into a calculator here and evaluate that. This is a Desmos calculator. It's an online calculator, desmos.com/scientific. So if we plug this in, we can say 5 volts divided by 0. And Desmos says that it does not know what we're talking about, right? It says that that's an undefined number. And I want you to associate undefined with infinity, right? Because undefined means it's so big we can't even give you a number for it, right? And so that's what our resistance is doing here. If we have no current flow, we must have infinite resistance preventing current from flowing, right? There's no pathway for current to flow. This other one over here does the same thing. It says, what happens when there is no resistance in I equals V over R? Right? No resistance in I equals V over R, that's going to look the same here. If we put 5 volts on top and a resistance value of 0 on bottom, we get left with an undefined value, and that's a dangerous value, right? That means we have infinite current. Infinite current means that we have a whole lot of heat that we need to get rid of, and it's probably going to stop the circuit all on its own for you, right? It's going to break the circuit and eventually go to that open state. It's going to hit back to this infinite resistive state eventually after it burns out a couple of components and loses its pathway for current to flow. Let us know if you have any questions about this.